and I'm going to introduce you to Vihana. Vihana is a 7th grader. She likes math and debate, and in fact, she's going to debate camp this summer so she can kill it in 8th grade. She came to me having already learned Python and C, so we tried to build on that. We did a top-down approach where we took code that already existed, and through a series of small experiments, she changed almost everything in the code and thereby learned what was going on. She hopes to become an engineer in the future, maybe something with wearables or fabric engineering, and she would like to go to school on the East Coast. And now I'm going to let Vahana tell you about her project.
Hi, my name is Vihana Gandhi, as Anouk mentioned, and I'm in 7th grade and I go to Rancho Middle School. Next slide, please. So, my mentor is Anouk. So, Anouk is like a radiologist who has a really special interest in AI, and she lives in Arizona, and she's been in magic since 2017. Next slide, please. So my project is called Is It Pneumonia or Not? So in this project, I use a Python notebook to train my model, and we use three simple things: AI. We combine three simple things: AI, medicine, and a data set. And I will go over these like topics and technologies later. Next slide, please. So first, in my data. Um, Next slide. So for my data, we used a data set from MedMist. It's a data set full of pneumonia X-rays, and there's about 6,000 of them. So on the left, left photo, you can see like an X-ray of pneumonia, and you can see it's like really hazy and dirty, and compared to the right, which is like a normal chest X-ray, and so you can like tell the difference between which one is pneumonia and normal. Next slide. So this is the distribution. So as you can see in the training set distribution, there is more pneumonia than normal, and this is because like the model needs to get used to classifying pneumonia, and some are really subtle, so it takes time. And in the validation set, it's like an equal amount of distribution, so it can evaluate the model. Next slide, please. So prepare data. So and like to prepare my data, we applied like lots of things like data augmentation, and then we added a mix-up, and then we split it into three sets so it could evaluate one each like time. Next slide, please. Now is the model and training. Next slide. So machine learning. So in this, we use like multiple models like Resonate 18 and 34. We picked like lots of different options, like image size. Like we use a lot of hyperparameters, learning rate, and we had to like repeat this about 60 to 100 times to get like get a high accuracy. Next slide. So some experiments we did were image size and model size, in which we went to like small images and models to big images and models. And then we played around with the optimizer and learning rate, and then we finally added mix up. Next slide. So behind the scenes, like behind like every decision, the model is constantly changing its weights. Next slide. So like weights are like a dial, and they control like how much an input's like importance is in a prediction. Next slide. And then now we have all these like weights, but when they get something wrong, we need a way to like measure the learning it makes, and we need to way to measure the mistakes. So this is where our loss function comes in. Next slide. So so the loss function, it like takes a loss, and then it measures how far we are from the correct like answer, and the goal is to like to reduce the mistakes over time. Next slide, please. So the optimizer, it takes this loss and it uses the loss to guide the model and to change the weights so the model can make like better decisions, which improves its accuracy. Uh, so in the training, so like a summary, so we fed the model with the X-ray images with like the labels of normal and pneumonia. We used the loss function to measure the errors, and we optimized it using multiple models to adjust the weights. Next slide. Measuring results. So this is like a distribution graph showing like our accuracy over like 100 epochs. And as you can see, it like stabilizes around 60 epochs. And then it ends up like when it reaches 100 epochs, it ends up in like the high 80s. Next slide. So this is a benchmark. So a benchmark is like a table, and it shows all the like way older people's than me, like the accuracy they got when they did this for 100 epochs. And as you can see, it like ends up in like the high 80s too, which aligns with mine. Next slide. So this is a confusion matrix. So the big numbers show where my model got it right, and the small numbers show where my model got it wrong. And as you can see, like where my model mostly got it wrong, when it was like predicted positive, but it was actually normal. And this is because some like lots of pneumonias are really subtle, and the model can't classify that much yet. So it's like that. Next slide. So this is my demo. Oh, okay. So I'll wait for it. So this is like examples of pneumonia images that you can do really hazy. And these are some normal x-rays. They're like really clean, as you can see. And then going back to pneumonia, it shows it's like really dirty. And so you can see like the real difference. So this is my training function. So it's like it takes all the model images and then it trains based on each image. And then the validation set, it evaluates the model like for each epoch, so about 60 to 100 times it does that. I'll wait for it to go down. So now I'm gonna run the model for 5 epochs. So, but while it's like as you can see, it's running, and while it's running, I'm going to show you the previous run on top. So this run, we ran it for 10 epochs, and the accuracy, so we like in general, we want the loss to go down and the accuracy to go up, which it did in this run. And so going back to the running, this was like just to show you how the model runs and how fast it does each epoch. And yeah, that should be it for my demo. Thank you. And, oh yeah, there's one more slide. My bad. Okay, so this is my magical experience. So some highlights of my experience were when it got to more than 90% accuracy, I was practically jumping up and down. And I learned a lot of stuff, like how to use hyperparameters and a lot of tricks like data augmentation, learning rate, and mix-up. And there were a lot of hard concepts to understand when the model became like really, really unstable. So during these times, I did not understand like these concepts, and so I relied on like ChatGPT to help me understand them at my level, and it did a pretty good job. Next slide. Thank you.
Thank you, Vihana. Incredible work. What a meaningful way to apply AI to healthcare. Are there any questions from the audience for Vihana?
I'll start if no one else. I'm always curious. So this was a great example of using AI and a little bit of machine learning in terms of the different images that you had to go through to build sort of a base set to understand what is pneumonia versus not, right?
Mm-hmm.
So I guess my question to you is, given this particular experience, what is your feeling terms, if you were able to get more sample in the model, what do you think your accuracy will be in regards to having the program identify if someone has pneumonia versus?
So all these x-rays that I found were like child x-rays. So they're like kids around my age who got classified with pneumonia. And so if it was supposed to implement other people's, like older people's x-rays, I don't know exactly if they like look the same as child x-rays. So I would have to train the model to look for more subtle patterns or more extreme patterns in those x-rays.
Okay, great, thank you.
I have one question.
Yes.
Do you think that AI will replace doctor one day?
I think AI can like help doctors, as I said, like I trained my model to. So I can think and help doctors. And my mentor, Anouk, she uses AI to help her with like radiologist like scans and all. So that's an example. And I think if we do that, like if we train more models, so we can go even further with that.
Yeah, I'm her dad, and I was just sad that they call me. When AI comes in, half of my family will be out of the business. They're all into the industry of medical profession. I'm the only engineer.
Are there any questions from the Zoom people? Yes? No? 7 no.
Zoom audience, any questions?
I can. I'll ask a question. That was really wonderful and fantastic, and I appreciated your answers to the previous questions. There were so many kind of machine learning concepts that you walked us through, and I'm just curious as to, you mentioned you used ChatGPT also as kind of to unpack some of those things. What was that? Was that your main approach? Did you also do some researching? Did you use a textbook? How did you kind of wrap your head around so many new topics?
So in the beginning, we did some exercise, like not exercise, like some techniques, and I like researched a bit about what the optimizer, loss function, like how to declare all the functions and all. But then when we went to like deep down, we like dived into it. Those harder concepts I couldn't really get, and Google, I still couldn't get it from Google. So then that's when I switched to ChatGPT because it gave me, like if I said at 7th grade level, it would make it like so easy to understand that I would ultimately get it.
Very cool. Very cool. Thank you. Wonderful job.
Thank you.
Thank you again, Vihana. Already on